I'm a 4.0 pre-med, and one thing about me is I study smarter, not harder. I make mnemonics and techniques to maximize studying, and hopefully I'll help you do the same. So last video, I gave a brief introduction to Newman diagrams, what they look like, but I got some feedback that they were still kind of confused how I drew the Newman diagram, because I did it kind of quickly and it was butane, and so I wanted to do that. I also again got feedback that I didn't do the energy diagram, which was not the objective of the last video. I just wanted to give an introduction to that concept. So let's get into more depth today. I'm assuming you watched the last video, so if you didn't, either check it out on my TikTok or go to my YouTube, and I have playlists and I have organic chemistry, and you can find it there as well. So this is what I want to explain more in depth today. So I try to draw it this way with colors, so that way you guys are going to be able to distinguish what I'm actually talking about and doing. So per convection, by convention, in organic chemistry, you have this part that I drew in purple shows the front of the molecule. The part that I drew in white shows the back of the molecule. So I'm gonna highlight it, and then so this, and this, all of those molecules are in the back, connected to a carbon, which you imaginarily don't see. It's there, but you can't see it. This center right here demonstrates that there is a carbon that it's attached to, okay, in the front. So as of right now, you know you have a CH3 attached to a C connected to a CH2. But then you have a carbon in the back that you can't see, so you know that there's another, and there's two hydrogens here, so it's another CH2. And lastly, you have this, so it's a CH3. So that's how I was able to ascertain, oh, this is butane. Okay, if you still don't see it, hopefully the way I drew it this time will make more sense to you. So let's look at it this way. I'm gonna again highlight, and hopefully things will make sense to you. So this CH3 right here is this CH3 right here. Again, this hydrogen right here is this hydrogen right here. This hydrogen right here is this hydrogen right here. This carbon is there, I promise you, and that's that carbon. Okay, that's the front. Okay, let's do the back. There is a carbon in the back, also in the middle, that you do not see, which is this carbon right here. Then you have this hydrogen right here, which is this hydrogen right here on the left. This hydrogen right here on the right is this hydrogen right here on the right. And lastly, you have this methyl group right here on the top is this methyl group on the top. I hope that this figure, and I'm going to blow it up, makes more sense to you. Take a minute, pause this screen if you have to, and make it make sense in your brain. I know it's really confusing at first, and I was trying to draw this circle to show you that it's this actual circle that I drew here. But again, this is something that you have to observe. I'm doing the best that I can with these colors, so that way you're going to be able to see it. When I used the colors, I was finally able to see it, to be honest with you. At first, it wasn't making sense where they were getting things from. But again, this is the left front. This is the right front. This is down front. Left front, right front, down front, middle carbon, okay? Back, left, back, right, back, left, back, right, back, top, and all of those are, again, there's a carbon that you don't see that it's there. this does not make sense to you, I'm really sorry. You're probably going to have to grab an actual model. I know that people that are even more visual and tactile and kinesthetic, there are molecular models. You can even buy it on Amazon. So I would recommend that. But for people that are still visual, that can kind of conceptualize, I think that this is a really good way for you guys to see it. Okay, so enough talk about conceptualizing. I'm assuming at this point that you understand how I got this and how I did this. So briefly, at the top, I don't know if you guys noticed last time, but I wrote here that this was 19 kilojoules mole per mole. So there's an actual chart. I don't have it on here, but it tells you, okay, like a methyl and a methyl, this is 11 kilojoules per mole. 2 hydrogens is 4 kilojoules per mole. Again, 4 kilojoules per mole. So 4 plus 4 is 8, plus 11 is 19. So that's why I put 19 kilojoules per mole. A methyl plus a hydrogen is 6. 2 hydrogens is 4. Again, a hydrogen and a methyl is 6. So that's 12 plus 4 is 16. So that's how I got the 16. Again, these that are staggered are going to have less energy. And then that's how you are going to put those values when you do this energy diagram, which I'm not going to talk about at this very minute because I just wanted to, again, give you a brief kind of introduction. But now let's talk about the actual rotation of the angles, because again, that was another criticism. But it was really an intro video, guys, so chill. Okay, so for this is, imagine this is 0 degrees, and that's what it is. So it can be 0 degrees or 360 degrees because it's the first thing that you have and then the last thing. Well, for my purposes, this is, I think, is the easiest way. So this is something I always tell students, particularly because they rotate both, and I'm like, you're doing a hot mess. Either you rotate the front or you rotate the back. I don't care what you do, but keep one the same and rotate the other one. So in this example, if you notice, the front on all of these is the same. The only thing I'm moving is the back. And what is the back in this molecule? It's this. I'm moving this, I'm moving this, and I'm moving this. Other than that, I'm not touching it, okay? Because if you do that, you're going to have a hot mess. I guarantee it. So you're going to move 60 degrees. So this thing is going to move, this thing is going to move, and this thing is going to move. So now it goes 60. It was here, now I move here, 60, and now I move here, 60. So this went 60, this went 60, and this went 60, okay? Now you're going to do the same thing. I keep erasing because I want you guys to see it. Now I'm going to move another 60, okay? And the same with the other molecules. And that's how I ended up here, okay? Now again, I'm going to move another 60. So again, this was 60 degrees. Now we're at 120 degrees. Now when I move another 60, I'm going to have my anti-conformation, which we talked about, is 180 degrees. Then I'm going to move another 60 degrees, and I'm going to have 240 degrees. And then I'm going to move another 60, and I'm going to have 300 degrees. And then when I move another 60, I go back to this figure here, which I told you was 0. So again, pause the video and look at it. If you don't like how I left the front and I rotated the back, try it on your own paper. Leave the back alone and rotate the front. It works both ways. This is not like you have to leave the front the same and rotate the back. No, that's how I prefer to do it. Now, if you, again, prefer to move the front and only leave the back the same, that works too. I've done it in the past, okay? So, I'm assuming you've paused the video, and I'm assuming that you know how I did this. Now, let's go to the actual energy diagram. So, kind of did it wrong because you're supposed to have like energy, I think kilojoules per mole, and then I forgot the actual name that they have, but it's usually energy. And then here is going to be your angles and all of my angles. So the math that I did in the beginning that I told you, okay, that's 16 kilojoules per mole. Oh, that's 19 kilojoules per mole. That's what you do. You do it for all of them. You do it for all of these figures. You add them and you get the math. And then you end up with this. And so, for example, here at 60 degrees, we saw that this is going to be an eclipsed, so it's lower in energy, but it is not going to be the lowest energy. What is the lowest energy? Like I said previously, the lowest energy is going to be the anti-conformation. Okay, then here on number 120, you're going to have, again, an eclipsed. But as you can see that we discussed in the last video, at the 0 mark, you have your two R groups stacked on top of each other, which is way more energy than your R group with hydrogen. Okay, so again, that's why number 1 was the highest. And since number 1 was the highest here, it's gonna have to be the highest here at the end because it goes back when you do your full 360 degrees. Okay, again, at the 120, it's still high energy. Why? Because you still are eclipsed, and eclipse is high energy, but it's going to be slightly less. So that's why you have it less than you did at the 0 degrees. Okay, now the 60 and the 300, like I discussed previously, it is going to be staggered, but anti-conformation, the one at 180, that they're 180 degrees away from each other, is the most stable and therefore the least amount of energy. Again, if you enjoyed this video, please go to my YouTube and check that out. I have playlists on different subjects. Like I said, I'm a pre-med student, and so I did this so that way you go to that playlist, click on the subject, and you have all my videos related to that subject to make your studying much more efficient. And thanks again for watching.